guys, welcome to another episode of MrLopezClasses.com. Today we are going to continue in our book of composite materials, and this is the chapter 2. In this chapter we are going to talk about the fibers, the different type of fiber, the carbon fibers and the silica fibers, the fiberglass and the carbon fiber, and how those fibers combined with different type of resin produce wonderful structures, heavy structures with excellent qualities superior than the qualities of famous ferrous alloys and non-ferrous alloys used in the marine industry. Yes, the carbon fiber and the fiberglass are every day more and more popular and replace the metals, the metal alloys every day in more and more applications. There are millions of examples in the automotive industry. A lot of manufacturers, they fabricate the chassis of the new cars in carbon fiber. Uh, Not only the chassis, the structure, the body in fiberglass and carbon fiber. And the same with bicycles, with the motorcycles, with the airplanes. The structures today in carbon fiber and fiberglass replace the majority of the famous metal alloys. We are going to analyze what happened with the fiber, and we are going to try to understand what is the meaning of fiberglass and carbon fiber. We are going to start with fiberglass. The other name for fiberglass is glass fiber. It's a material made from fine fibers of pure glass. What is glass? Glass is silica, you remember? And silica, if you remember in the periodic table, is located in this group, in the group number 4. In the group number 4, we have a silica, and we have those three elements, famous carbon, silica, and germanium. Those three elements that they are called semiconductors, because in some cases, depending on the temperature, those elements work like metals or non-metals. Yeah, those magic elements. And carbon and silica are located over there in the group number 4. What is the meaning of that? Those elements, they work when they try to be combined with other elements, they work in the last orbit, the valence orbit, with 4 electrons. If you remember, the octet rule states that when an element tries to be stable, the element tries to complete a electron in the last orbit or 0. This is the octet rule. Carbon, in order to be stable, needs 4 additional electrons in order to complete 8. For that reason, the structure of silica glass, because glass is pure silica, is a perfect structure because it's pure silicas connected together in a perfect structure. That structure doesn't need any other element to be stable. And additionally, those structures not react. Those structures are stables. If you try to add chemicals or other elements, those elements not affect those structures in carbon fiber and silica fibers. Look at this. This is the typical fiberglass structure. Are silica elements with 4 electrons in the last orbit, and those 4 electrons they are related with the other 4 elements of the next neighbor silica, producing a strong structure. This structure is completely stable. This is a stable structure. If you see, you don't have impurities. You don't have external elements mixed in that structure. This is a structure of a pure silica, and it's perfect because those relations in between one silica and the other one of the neighbor elements are covalent reactions, and they share electrons with the neighbor silica. Exactly the same occurs with carbon. Because carbon is also in the group number 4, have the same behavior that the previous one with silica. Both structures are perfect. Both structures are completely stable. They don't react with the external elements, chemical, oxygens, attacks, because they are stable. That's wonderful. This is magic because additionally, when those structures are covered with the resin, epoxy resin or a polyester resin, produce structures that are in some cases in tensile strength and compression strength have superior properties than metals and metal alloys. Yeah, it's the industry of the aviation industry, the marine industry, have a division before carbon fiber and fiberglass, and after that, because the life of the marine industry before those materials, carbon fiber and fiberglass, was completely different. Depend basically of a wood and a specific type of wood. And today is completely different. That industry depend not only of those structures in fiberglass and carbon fiber, but there are a lot of wonderful non-ferrous alloys that in combination with those structures create wonderful boats. Yes, the majority of the new boats, they have a combination of both of them, structured in fiberglass or carbon fiber with reinforced of special aluminum alloys. Yeah, in sailboats, in power boats, we found that those combinations. And we are going to check later in next coming episode that situation. For that reason, today we are going to talk about those elements and the properties of fiberglass and carbon fiber. We are going to start basically with the fiberglass. Fiberglass is not as strong like a carbon fiber, but it's great. It's great and is used in different type of applications. Fiberglass is a non-conductor. For that reason, fiberglass is used like an insulator, isolator, and is invisible to the majority of the transmissions. It's a good choice for electrical fabrication of electrical components and broadcast application. It's excellent. Yes, depending of the resin, you have different structures. You can cover it the fiberglass fibers with the polyester resin and also with epoxy resin. With both of them, with the polyester and with epoxy. With both of them, you can cover the fibers in glass. Yeah, and the result is wonderful. It's magic. Yeah, and we are going to check right now other properties of fiberglass. It's an elastic solid. Carbon fiber is more elastic in comparison with the fiberglass. It's based on silica, remember, and is stranded in small fibers. In some cases, those fibers are twisted to create a yarn. That's the typical structure of a fiberglass. It's a good thermal insulator because have a low thermal conductivity. It's weak in tensile strength in comparison with the carbon fiber, but it's enough. And it's more ductile. And in comparison with carbon fiber, glass have a more elongation before it breaks. Let me I check that structure. Look at this. This is the situation of fiberglass with a polyester resin or with epoxy resin. And this is the difference. This is the maximum Young's modules of fiberglass mixed with the polyester resin. This is the point number one. And this is the Young modulus when you have a fiberglass covered with epoxy resin. Yeah, with epoxy resin you reach higher Young's modulus. Now we are going to analyze the different type of fiberglass used in marine, automotive, aviation industries. And we have A-glass, is alkali glasses, the number one. Alkali glasses is a good chemical resistance, but have a lower electrical properties. The C glass is the chemical glass, have a great resistance to chemical products. The E glass is excellent for electrical purposes because it's an electrical insulator and resists the attack from water. For that reason, is used in marine application, the E glass, and also the S glass because it's an excellent in The S glass, structural glass, is used for your excellent mechanical properties. Both of them are used in marine applications. And the D glass is a dielectric glass, have the best electrical properties, but have a lack of mechanical properties in comparison with E and S glass, commonly used in marine applications. Properties of fiberglass. Fiberglass is a great thermal insulator, is a great electrical insulator, is good for reinforced, is good for temples, for sound absorption. For that reason, is commonly used in residential application for the fiberglass, the insulator that you have in the roof in your home. Insulator for sound, insulator for temperature. Yeah. It's excellent in strength. It's used in automotive. It's used in the fabrication of holes and in the fabrication of electrical insulators like breakers and switches and other electrical devices. Yeah, this is the foam used in your home, that one. Be careful because this is only for insulation of sound and insulation of temperature. It's different like the structural foam used in marine application. The structural foam used in the reparation of ball heads, stringers, and transoms. We are going to explain later with Galvin, one of the guest speakers that we have today in our conference. The fiberglass used in marine industry is different from the insulated fiberglass. The fiberglass used in the marine industry is commonly in mat, in cloth, and chopped in a strand, mixed with resin for different applications, basically in the fabrication of hulls and his structures. This is the uses and applications of those elements. Fibers. The fibers are commonly in woven and mat, both of them, woven and mat. And before we try to understand those fibers, I want to check the explanation of those different type of fibers from Galvin. I hope you enjoy that video clip. Alvin, this is the most common mat, no? What is the name, the technical name of that?
Okay, this is 1.5 mat. Is you want to use this. There's also another 1.5, which is a little thinner than this one.
Okay.
That allows you to begin your work. This is just a start. It's not really as strong as the cloth. There's a difference.
That's different. No?
This is a cloth, which is stronger and sewn in different directions. So you got to know how to.
In one side you have a smoother, and the other one.
Because this, you always wanted this part to go down to onto this one.
Okay, but this is stronger than this one.
This is a cloth. This is a mat.
This is the cloth. This is the mat.
Yes.
That's perfect. Okay, that's good.
And this is 1.5, and this is 1708.
Correct. And what about when you founded those pieces of like this exactly?
Okay, this is what I use. Like maybe I'm patching a hole, screw hole, and you don't want to screw holes no more. I cut these up and I mix it with the resin.
With the resin?
And I stick it in the hole. Rather than just sticking a bundle.
Correct. Instead of bundle. Or you use this one. What is the name of this silica balloon? No?
Yeah, this is by Q-Cell.
Correct. Q-Cell.
You can mix this with the resin also.
Resin, correct.
But it's no strength if you want to use it for a hole. So that's why I use these.
Because this is a strength.
Yeah, this is what makes it strength.
Ah, this is the typical to prepare putty, no?
Yeah, like a finish, like you want to level out something,
correct.
Skim on something.
Correct.
Build this up with.
And this one for
like doing holes.
Holes,
and a little,
correct.
Yeah.
Oh, okay, that's wonderful. Right. That's perfect. And any other type of mat?
Yes. This is a very strong mat. It takes a lot to really saturate in order to get it all really smooth.
This is the last one, no?
One that it's very strong.
Yeah.
It's heavier, so it takes more of the resin to saturate it and get it really even out. But it's a good mat to use. It's a good it's called a woven.
Woven robin, yeah.
Yes. But this is what you want to use in areas that is not going to be finished, because if you're going to finish, it's going to take more to finish. So you want to smoother after.
You need a lot of resin with this.
Yes. But you can use it to build or to rebuild anything. But in order to have it smooth out, you want to go with this after and then finish it up.
And then finish with that. Ah, okay. This is the process.
Yes.
This is the process. Ah, okay. All right. And always with the roller and a brush, exactly the
Well,
same.
you're better off with a roller because the roller puts. With a roller,
Yeah, that's okay.
you're able to push the ear. You're able to push the ear. I don't have the.
The longer, yeah, no problem. But it's okay. It's okay.
You're able to push it out and push the ear out.
The roller apply better.
Yeah.
Okay, and you always clean everything with acetone, no?
You have to clean it up because that's what allows you to bond properly, clean surface.
The same for the tools. You clean the tools at the end of the day with the acetone.
Yes.
Yeah.
But not the end of the day, because if you leave it for the end of the day, it's going to be dry. So as soon as you finish using it, you just want to clean it up. Even your gun, you want to clean it up. You want to clean your tools up right after you finish using it, because if you allow it to dry, then you're going to have to grind it off.
Okay, perfect,
So
perfect.
once it's still wet, once it's still not dried yet, you want to clean it up and then lower them to dry.
Okay, and now it's clear for us the difference between matte, the woven robin, and those are the mattes, and those are the cloths. And this is the surface. The surface is completely different. Yeah, and normally in 4 layers. At the beginning you start with matte, 2 or 3, and after that is the cloth, and the cloth is basically the final, the external surface, the appearance. Yeah, there are different type of cloths with different type of textures, different type of colors, but the most commons are those. Kevlar. Kevlar is a high modulus strength. High modulus strength. Right now we are going to analyze what is the meaning of that, and it's a product of DuPont. DuPont is the trademark, and the other one is woven robin. You remember Alvin explained the woven robin. The woven robin in different thickness for external surface. It's structural, it's heavy, structural, and require a lot of quantities of resin. For that reason, the preparation should be appropriate. And yeah, this is the number one is the matte, the typical matte in different thickness, like Calvin explained. And the biaxial, this is the 1.5, and this is the 3/4 ounce matte, depending of the thickness, and normally is coming in 45 degrees angles, cross 45 degrees. Yeah, this is wonderful in the fabrication of stringers, transoms, and holes. And now we are going to start with carbon fiber, and we are going to analyze the comparison in between fibers of glass and fibers of carbon. We are going to check what is the meaning of carbon fiber. Carbon fiber, or graphite fiber, is a material consisting of extremely thin fibers in between 0.005 and 0.01 millimeters. Is practically a hair. Is too thin. The carbon atoms are bonded together in microscopic crystals. Remember that the carbon atoms, depending how they are organized, produce the most strongest surface on the Earth is the diamond. The diamond is basically pure carbon. Incredible, no? And the graphite that is used for like a lubricant is also carbon molecules. Incredible how depending of what? Depending of how is organized the atoms of carbon, and depending of the pressure and the temperature. Yes, for that reason you found a different type of diamonds with different colors. Yeah, but the most famous is the completely clear, transparent diamond. This is considered a pure diamond. Remember that the synthetic diamonds produced on the laboratory, they have like a blue appearance. It's produced on the laboratory. It's hard, but the appearance is a little different, like the natural diamond, completely transparent, completely clear. Yeah, depending how is the organization of the atoms, you have a complete different structures with the same element, carbon. Carbon is magic, exactly like a silica. Silica is magic, and iron. You remember iron? How magic is iron? Depending depending of how is the alloy, you obtain different steels, different cast irons, and also iron by itself is magic because it's magnetic. Yes. This is the unique metal with those properties because iron is that we have electricity, because iron is that we have the telecommunications, the internet, the majority of those wonderful tools that you have in your hands today. Magic elements, carbon and iron, both of them are excellent. The Young modulus of carbon is magic. Let me explain what is the meaning of that. You remember this definition? This curve, the curve of strength versus deformation, and this is the curve. This is the curve, and this is the maximum Young modulus, that point. And this is the area here in this side is the elastic area. This is the elastic area. And the area over there in the green area is the plastic deformation. In other words, this is the point of reference. This is the point where the material passes from the elastic area into the plastic area. What is the meaning of that? Elastic area is the area where you can deformate the material and the material return to the original position. In the plastic area, when you deformate the metal, after that point, the material stays deformated. This is the point of reference, the point where the material passes from the elastic into plastic. Yeah, and this is the break point. This is the point of fracture or break point. This is the typical curve that we analyze with the steel, you remember, with iron in previous episodes in our book of corrosion. And depending of this is the Young modulus. This is the maximum Young modulus. Depending of the Young modulus, the carbon fiber is organized like a low modulus, a standard modulus, intermediate modulus, high modulus, and ultra high modulus. It's depending how are organized those fibers. You have medium, low, high, and ultra high. And depending of those classifications, you can use those structures for fabrication of the frames of bicycles and motorcycles, for the fabrication of chassis, and for fabrication of heavy tensile and compression structures. Okay, my friend, and don't forget that carbon fiber, carbon is an organic material, For that reason, carbon in combination with oxygen, hydrogen, and nitrogen is basically an area, a big area is considered the organic chemistry. There are chemistries, engineers dedicated to study the rest of the life only carbon, and its structures. Carbon, organic chemistry. And yes, this is the typical curve that I explained before. This is the high tensile strength is around 77 millions of psi. Yeah, this is the curve of deformation, stress versus deformation. And this is the curve. Yeah, this is the curve as here, and this is the fracture point. It's exactly the same like the previous, and this is the elastic area, and this is the plastic area. Now we are going to analyze uses of carbon fiber. Carbon fiber is commonly used in textiles, aerospace, civil, military, in competitions, and is used in the fabrication of hulls, poles, and in different type of structures. Carbon fiber every day is more popular. It's expensive in comparison with the fiberglass. Right now we are going to analyze, but it's wonderful. Those are the properties of fiberglass in comparison with the properties of carbon fiber. Fiberglass normally can be combined with polyester resin and epoxy resin for fiberglass. However, carbon fiber should be combined basically with epoxy resin. Can I use polyester resin with carbon fiber? Yes, but the final structure is not the best. For that reason, the recommendation is with epoxy. What is inconvenience of fiberglass is too rigid, is brittle, and the cost is low cost. In comparison with fiberglass, that the problem in comparison with the carbon fiber, that the inconvenience is the high cost. It's too expensive. Is one of the inconvenience. And this is a wonderful table that with the comparison in between fiberglass and carbon fiber, and we analyze the density, the tensile strength, the compression, the surface, the fatigue, resistant to high temperature, resistant to moisture, and we have this is poor, this is excellent, this is poor, this is excellent, depending of both of them. I recommend analyze this table. This table is part of our book of composite materials. You can buy the book in our webpage at www.mrlopezclasses.com. And those are the comparison in between the mechanical properties of fiberglass with the mechanical properties of carbon fiber. And remember that the different type of fibers in carbon and glass. The most common type of fiber and carbon structures are these. In carbon we have the a.s.c.r, the im7, the most common. And in fiberglass we have a S-glass and E-glass, like I explained before. I am talking about the marine application, don't forget that the carbon fiber structure have an excellent appearance. It's used to cover the final product because it's nice. The appearance, the structure of the carbon fibers covered with the resin and polished after that produce a wonderful surface. There are fiber cloths like this. The 3K is a carbon fiber cloth, is a staple carbon cloth, is used in boat builders, in automotive applications. This is the appearance of this. And this is the other one, carbon Kevlar hybrid. Is a hybrid in between carbon and fiberglass. That's wonderful. The appearance is nice, and is covered with the epoxy resin, produce excellent structures. And this is the other one. It's like a tape in a carbon fiber mat. And when you remove the adhesive, start the reaction. When you remove the adhesive, the oxygen enter and start to affect that the catalysts produce, accelerate the reaction, and the surface dry in 2 hours, 3 hours, and you have excellent appearance. It's used in the automotive industry to cover the wheels, to cover frames, and produce excellent external surface. It's coming in different colors and in different widths and lengths, and is impregnated with adhesive. Immediately you remove the paper protecting the adhesive, start the reaction, and the carbon structure dries. Wonderful carbon fiber and fiberglass fibers used in marine applications, is widely used every day, is more popular. And don't forget that you can combine those structures with the structures in aluminum and with the structures in stainless steel in order to create magic final products.